All right, let's look at question 2 from assignment 14. A ball is thrown upward from the top of a 100-foot high building at a velocity of 80 feet per second, which is really fast, not a reasonable amount to throw it. The ball's height above the ground, well, here's the initial height, 100 feet. Here is the initial velocity, and it's directly upward, so we use the entire amount. In trig, when you have trig, you'll see that you multiply this initial velocity by the cosine or the sine of the angle at which you throw it. But if we're throwing it straight up, we're going to use all of it. And then 32 feet per second squared is acceleration due to gravity in feet per second squared. So we multiply that by -1/2, and that gives us our height function in terms of time. So we want to find how long it takes the ball to reach its maximum height. Well, let's see, we've got h of t, negative 1/2 times 32 is -16, plus 80t plus 100. Since a is negative, then the vertex will be the max. So we need to find the vertex. The t coordinate is -b over 2a, so -80 divided by 2 times -16. So that's -80 divided by 32, -32. And we can divide some things out here. Let's see. Let's divide both by 8. That gives us -10 divided by, let's also get rid of the negatives, divided by 4. So we can divide again by 2. And that gives us 5/2. Oh, good, that's not too bad. I'm checking something really quickly. Hey, yeah. Okay, it's always nice to know you're right. So at a time of 5/2 seconds, well, 5/2, that's 2.5 seconds, the ball will be at its maximum height. We'll find that maximum height by plugging 2.5 into our function. So h of 2.5 is -16 times 2.5 squared plus 80 times 2.5 plus 100. That's -16. Let's see, 2.5 squared is 6.25. $80 times 2.5 is 200. That's 116 times 6.25. Oh, that's cool. It's also 100. So we've got -100 plus 200 plus 100. So 200 feet is the highest that the ball will be with respect to the ground. That's kind of an amazing thing. And then they want to know how long it takes the ball to land. And just like we did in the previous problem, this time we've got the building, which is 100 feet. The ball goes up and then down. We found our max already. The coordinates of our maximum point are 2.5, 200. So 2.5 seconds, 200 feet. And now we want to find the t-intercept so we can see how long it took the ball to land. Well, that means we want to set our original quadratic equal to 0 and solve for t. So we've got 0 is equal to negative 16t squared plus 80t plus 100. And just like we did on the previous problem, I want to divide out this common factor. I see that 4 is common. But let's divide by negative 4 so that we end up with a positive a. And the main reason we want that is the quadratic formula has a in its denominator, and it's a little confusing if a is negative, whether or not your answer is positive. So this gives us 0 is equal to 4t squared minus 20t minus 25. And that's not so horrible. So we have t is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So negative times negative 20, because b is negative 20, plus or minus b squared, so negative 20 squared, minus 4 times 4 times negative 25, divided by 2 times 4, 2a. Well, this is nice, because 4 times 25 is 100, times 4 is 400, and we're adding. So we've got positive 20 plus or minus. 20 squared is 400, and we said that this amount here is 400, all over 8. So we've got common factors all over the place. That's interesting. Okay, so now all we need is the approximate square root of 800. And I see that that is 28.9. So 20 plus or minus 28.9 divided by 8. And do you notice that if the square root term, if the 28.9 is negative, our numerator is going to be negative. And if the numerator is negative and the denominator is positive, the whole fraction is going to be negative. So we want just to consider the positive. And for the same reason as in the previous question, and we can do that easily because we made it. We can only do this when we have 0 on one of the sides, but we forced a to be positive. Okay, so now we've got 20 plus 28.9 is 48.9 divided by 8. 48.9 divided by 8, and that's 6.1, I think. So it takes approximately 6.1 seconds for the ball to land. So the last thing I want to show you is the graph of this curve. And you can see that the maximum does indeed occur at 2.5 seconds, and it is 200 feet. And I was not very accurate on my rounding, but it's 6.03, I think, seconds where the ball lands. Okay, great.